This time I will discuss frames. So what is the difference between frames and truss? So in truss we saw that all the joints are pin connected. All the joints in a truss must be pin connected. And second, all the loads will act at the joint only. That is truss. For frame, these two conditions do not apply. That means load may act inside a member. Inside a load can be acted anywhere. Inside a member, in the joint, both. And joints may not be pinned. Joints may be pinned, may not be pinned. So if these two conditions or any of these conditions apply, then it will be frame. If none of these apply, then that will be truss. So in our last chapter, we discussed truss, and this chapter we will discuss frame. So what is the difference between truss and frame? Is this, that in truss all the joints must be pin connected. Loads can act only at the joint. For frame, any of this may not apply. So, and regarding the analysis procedure is almost same depending on the situation. Now, I should not say exactly same, it is not exactly same, but the equilibrium concept will work. Now here I am showing one example. So here I drew one frame. How do I know it is a frame? Why it is not truss? Because you can see the load, it is at the member. So it is not a truss. If this load was not here and load at the joint only, then this is pin, this is okay. Let me draw here. Same thing. If this member if my structure was like this, pin, load at the joint, then it would be a truss. But in this case, my load is inside my member, so it is a frame. In truss, all the members are two force member. Two force member means if I take this member, my force here is either tension or compression. In my frame, there might be some force this way, there might be some moment that way, whatever it is. So in frame, there might be some shear force, that means some force transverse to the member, there might be some moment inside the member. So that is something new for frame. Okay, if we want to solve this frame, so what is the question here? The question is asking, determine the support reaction at A, B and C. So that is the question, determine reaction at A, B and C. Now something else from truss. In truss we knew that if my members are pin connected and no load in the joint, then that member is a two force member. You can see here, this is pin, no load inside member. So this member is a two force member. Two force member means the load in this joint is axial, either tension or compression, whatever, or compression. So this is something to remember. Now if you cannot identify, there is no problem. There is no problem if you cannot identify. What will happen? If you cannot identify, then there will be one reaction like this, other reaction like this. So you will get it. That is also okay. Okay, so if I want to find my reaction at A, B and C, what I will do is step number 1, draw free body diagram. Then apply equilibrium equation. So if I you can see that if I draw free body diagram, there is a AY reaction here, and say AX is here. Now you can assume downward, you can assume this way, no problem. Whatever you assume, if you get a negative sign, then it is opposite. So say here CY, say this is CX. Now, if you take a moment here, you can see two unknown because both will give you moment. If we apply summation of fy, two unknown, summation of fx, two unknown, so nothing is working. What to do? There are so many ways. Simple way, you can detach here. If you detach here, what is this? It's a pin. So whenever you are drawing Fibonacci diagram, whenever you are detaching, be like attentive there. Okay? If it is a pin or fixed, that means rigid, you have to be careful. So in statics class, typically all the frames will be very easy. So mostly it will be pin. If it is not pin, do not get worried. If it is not pin, do not cut here. There will be some other ways. I cannot give you a single recipe that will solve every frame or every task, not like this. Based on the structure, you have to decide. It is a pin, so I can easily detach. Now, what is the benefit of pin? If there is a pin, there is no movement here. That is the benefit. There is a pin here, no movement, only reaction. So if I detach here, then I can draw my Fibonacci diagram. Say I am assuming this way is my bx, and say this way is my by. So same thing here. It will be opposite. So in this way, bx will be this way, by will be this. So this is bx, this is by. Now there is no moment here because it is a pin. Now you can see as I detached, my life become very simple. I can take moment, I can consider only this portion, I can consider this portion, whatever. If I consider this part, BC member, so this is BC member. If I consider BC, and I am, if I take moment at B, so summation of moment at B is 0. If I consider summation of moment at B is 0, say assume a sign, say clockwise moment, this moment positive. If I do that, then what is the moment created by this distributed load? So this is 2 kilonewton per meter in 6 meter. So what is my combined load? 2 kilonewton per meter times 6 meter is actually 12 kilonewton. 12 kilonewton. Where it is acting at the middle. How do I know at the middle? Because it is a uniformly distributed load. Its centroid is at the middle. So this will be 3 meter. So what is the moment by this? Moment by this will be 12 kilonewton times 3 meter. Is it positive or negative? Positive. Because I assumed clockwise positive. My next moment will be produced by this load, Cy, that way, counterclockwise. So that will be negative Cy. What is the distance? 6 meter that way. So it is 6. Why negative? Because this moment is counterclockwise, so it is negative. Cx will not give me any moment because it is going through this point B. So it will not twist it, it will just hit it. No moment by Bx. So we found it. Then if I solve it, I will get Cx is 3 times 36, 6 kilonewton. So I got 6 kilonewton. I got this value positive. What does positive means? It means whatever sign I assumed, it is right. So my direction is upward. So Cy is done. Then, as I know Cy, now I can find By. How? If I consider this portion again, and if I apply summation of Fy, upward say positive, and again I am considering BC member. I am considering BC member only, not the entire. Then upward say positive Fy, so By is upward minus 12 kilonewton downward plus Cy, upward is 0. This value I know 6 kilonewton. So my By will be 6 kilonewton also upward. So I got my CY, I got my BY, BX, CX, I do not know now. How I do not, what can I do? If I apply, in BC member, if I apply summation of fx is 0, and say right side is positive, that way positive, that means bx positive minus cx equals 0, so bx equals cx. Now I know this bx equals cx, but I cannot tell the value. We need some more calculation. Okay. So I cannot do anything in BC member. Now, if I take AB, you can see I do not know bx, but I know by. So yes, this will give me some answer. Now, if it doesn't give me any answer, what can I do? I can consider the entire frame again, or now, but I am not going there because there are so many ways you can solve any structure. So whatever, when you are solving it, whatever way you can find the answer, do it quickly. If I take this one now I know by, so by is now 6. You can see at this side I assume by up, this side will be down. So always at any point, if that side is up, this side is down, that's why they will balance each other, it will be in equilibrium. So if I take now AB member, this portion, and if I take moment at A, so summation of moment at A is 0, say clockwise moment positive, I'm taking moment here, first is 6 kilonewton. What is the distance? 3. So this distance is 3 meter. Then bx that way. So minus px that way. What is the distance? The distance will be now this distance. What is this distance? 4 equals 0. No other force. Now, when I took 6, my distance was this distance 3. When I am taking this component, my distance is 4. So be careful about the distance. Distance must be perpendicular. And no other force. If I solve it, I will get bx equals 18 kilonewton times meter divided by 4 meter. So it will be a fraction. 18 divided by 4. It is 4.5 kilonewton, and I got a positive number. Positive number, that means whatever my sign is, whatever the sign convention whatever the direction I assume, it is right. So I got this one 4.5. You can see here in the past we saw bx equals cx. Now I got bx. So what is my cx? Same thing. So we can say therefore cx is also 4.5 kilonewton. So I got bx, by, cy, cx. I got everything here. I did not get anything here. Okay. Now if I take only this member again, whatever I was doing in AB member. So if I take this member AB, if I do summation of fy is 0, summation of fy in AB only, say upward is positive, so ay is up, 6 is down, no other force 0, so ay is 6 kilonewton, and we got a positive number, so whatever sign I assumed, it is right. So that is my ay. What is left? Ax. If I consider AB again, so AB again, and if I apply summation of fx is 0, ax equals bx. So ax equals bx, and we found that value is 4.5 in the past. So I got ax also, and ax is, I got positive number. That means the direction is this. Okay, so I will erase some portion here. Uh, so so I solved entire frame. If I want to show the answer, so my AX is 4.5 kilonewton and this is that way. AX that way. If I show my AY 6 kilonewton upward, and then CY 6 kilonewton upward, CX 4.5 kilonewton this way I found. For BX and BY, I cannot show any direction. It depends on the side you are taking, this side or this side. So for BX, BY, we just simply BX, BY, we just simply list the answer. For BX, BY, we do not show the direction because it is internal. If I take this side, it may be this way. If I take this side, it might be this way. So for internal pin, we do not show the direction. So this way I found the reaction at A, B, and C. Now, as I solve this problem, so this problem is solved, but just I am extended it so that you can understand better. And now, in the exam or in FE exam, the same problem. If there is a problem like this, say pin here, load here, fixed support here, roller support here. Here it was like this, inclined. Now if I make it everything horizontal, can you solve it? You must be able to solve it. Same procedure. What can you do? Yes, you can consider entire one. You can detach here. Something else you can see, this is a fixed support. So one reaction here, other reaction here, there is a moment here because this is a fixed support. This is pin. So this way, if it is this, that side it will be this. And then you can apply another reaction here. So instead of inclined, if the example give you a horizontal beam type member, I believe that you can solve this. So I will stop here. In the next video, I will solve another frame problem. Thank you.